Assalamualaikum students, this lecture is about the details of backward Finite differences. BFDs, backward Finite differences. Okay, just like in case of FFDs, we can define what we say zeroth BFD, zeroth BFD, and for BFD we use the symbol del, and del 0 means zeroth BFD. Okay, and del 0 f of x, that would produce the function itself. Okay, that means del 0 means the value of x will not change, so that's why del 0 f of x will come as it is to be equal to f of x. Or what do you see, if you take particular value of x, and in that case you write it like this, del 0 f of xi will be coming to be as it is f of xi. So this is the definition of zeroth BFD, and the first BFD is written like this. That is del 1 f of xi for particular value of x. Means when we are standing at particular value of x, in that case first level BFD is defined like this. That is f of xi minus the value of the function at xi minus delta x. Okay, or in terms of y, what do you say, if you write it like this, del 1 yi, that written as yi minus yi minus 1, where yi minus 1 is actually equal to f of xi minus delta x. Okay, and just like that we can also define the second level BFD. That is a second BFD, and that is symbolically written as del 2 f of xi. Okay, so this can mean this del 2 can be broken down into two pieces, del 1, okay, of xi. So first of all, the del 1 inside the bracket will operate upon the function in a BFD style, and we will be having an outer del 1 will be taken as it is, and we will have here f of xi minus f of xi minus delta x. Okay, after getting this result, now the outer del 1 will operate upon f of xi and f of xi minus delta x. So we will be having here delta 1 f of xi minus del 1 of f of xi minus delta x. Okay, so this del 1 f of xi will produce the result like this, f of xi minus f of xi minus delta x, and this del 1 will produce the result like this. This is a f of what do you say, xi minus del x minus what do you say, f of xi minus 2 del x. Okay, according to the definition of BFD operator, or the BFD operation, in del 1 f of xi minus delta x, this is the current value of the function f of xi minus delta x. So f of xi minus delta x, and we will decrease xi by one more delta x. This will become, the value of the function will become f of xi minus 2 delta x. So the difference will provide us the value for del 1 f of xi minus delta x. Okay, so our bracket can be opened down. This is f of xi minus f of xi minus delta x minus f of xi minus delta x and plus f of xi minus 2 delta x. Okay, now this one and this one can be collected and the result will be f of xi minus 2 f of xi minus delta x and plus f of xi minus 2 delta x. And in terms of y, this can we do? We know that f of xi is yi and f of xi minus delta x is yi minus 1. So this is minus 2 yi minus 1 and plus yi minus 2. Okay, so this is what you say the result of second level backward finite difference. Okay, just like this we can write down the result for third level BFT, fourth level BFT, and generally nth level BFT. So we will write down over here the nth level BFT result. Okay, look at. So generally for nth level BFT, del n f of xi r, it is written as del n yi, and this is written like this. We say del n minus 1 and inside the bracket that is del 1 by I, and that means del n minus 1, and del will give the result yi minus 1, and this del n minus 1 can be written inside along with each value of y, that is like this. Okay, so this is the general, what you say, general level BFT operation. Okay, just like we did in case of FFDs, power finite differences, we can also write down here a table of BFTs, right? Like this, look at. So the table of BFTs. Okay, so if we have the data to be, what do you say, xi and yi, and yi written as del 0 yi, okay? And if the values of x are x0, x1, x2, x3, and x4, so, and the values of y at these values of x are y0, y1, y2, y3, and y4. Okay, so these values of y are themselves what do you say, zeroth BFT values, and the first BFD values can be written like this. And in case of BFD table, we write the result in front of, let's say, leaving one value of y, and we write the result in front of y1. So this is y1 minus y0, that is written as, what do you say, del y1. Del y1 means the value of y1 minus the previous value of y. And over here in front of y2, the result for first level BFT is written like this: del 1 y2 is equal to y2 minus y1. And just like that, del 1 y3 is written as y3 minus previous value of y, that is y3 minus y2, and then is what you say, del 1 y4, and then it is written as y4 minus y3. Okay, so this is the column for first level BFD, and the second level BFD, that is written as del 2yi. Okay, just like that. Now we will look at the previous column and we will leave the first entry and we will write the result in front of for the second entry. And so over here we will write it del 2y2, and this will be equal to actually del 1y2 minus del 1y1. Okay, so over here we will be writing down del 2y3, and this will be written as del 1y 3 minus del 1 by 2. And just like that, over here we will be writing down del 2 by 4, and that will be del 1 by 4 minus del 1 by 3. So this is for what do you say, the second BFTs. And just like that, we can write here what do you say, uh, third BFTs over here del 3 yi, and over here again we will be leaving this entry and we were writing the result in front of this next value. So this will be what you say, delta 3 y3, and this will be delta 2 y3 minus delta 2 y2, and the last one is delta 3y4, and this will be actually equal to delta 2y4 minus delta 2y3. Okay, now for the last column, that is del 4yi, that means fourth level uh, fourth level BFT, and we will leave the first entry in the previous column and we will write the result in front of the what do you say, the last value of the previous column. So over here we will write in here del 4 y4, this will be actually equal to the difference of the third level BFTs. Okay, like this. Okay, so the table is completed. So this is the table of backward finite differences. And by the way, this table is also called as horizontal table of finite differences because the entries are coming in a horizontal style. Okay, so advantage of this type of table is just again for the process of what is numerical differentiation and numerical integration in case of while we consider the backward finite differences. Thank you.